Welcome back, everybody. In this video we're going to be taking a look at the port roles and the active topology, because the fact that we need to understand some of the details behind this stuff. So the first one is going to be the root port, which provides the best path, the lowest cost when the switch ports packets to the root switch. This is always going to face towards the root port or the root bridge. We have the designated port, connects to the designated switch, which incurs the lowest path cost when forwarding packets from that LAN to the root switch. So designated switch is always going to be a landing point. So designated port is going to be forwarding, where the designated switch is going to be connecting down. It's almost like the first network device that you attach to get to the network. So it's your network attach point, if you will. You have the alternate port. Offers an alternate path toward the root switch provided by the current root port. A backup port is a backup path to the provided by a designated port forward and leaves the spanning tree. Basically, the idea here is if I have a connection, two uplinks going to the root bridge, and I have two uplinks going down to another switch, and there's three switches in the stack, or three switches in the path, I should say. One of those uplinks to the root bridge is going to be active, one is going to be alternate. I have a downstream port which is designated, and I have another one that is designated as well, but that one's in backup. And I have disabled, which is not doing anything in the network at all. Now when it comes to rapid convergence, we have edge ports, and this immediately transitions to the forwarding state, as we previously stated. And we have the root port. Now, if there's a new root port, what ends up happening is spanning tree protocol blocks the old root port and immediately transitions the new root port to the forwarding state. This is how it's able to recover from a failure. And then we have the concept of point-to-point links, which negotiates a rapid transition with the other port by using the proposal agreement handshake to ensure a loop retopology. Now the way this works out is if I was to come in here, and beyond that we can go ahead and I'm going to go ahead and minimize and close out Wireshark, quit without saving. I'm going to go ahead and on all these uplinks, where there's a port channel or an uplink, I'm going to configure them all to be point-to-point. So that means on switch 1, I think I did this for everybody, switch 6 as well. Yes, so I'm going to go to do show CDP neighbors. I'm going to go to do show interface trunk. I'm going to go to interface port channel 46, and I'm going to come in here and I'm going to state that this is a spanning tree link type is going to be point-to-point. And the same thing with 2/0 and 2/1. So interface range gig 2/0 through 2/1. Do show spanning tree. Now what you'll end up getting is you'll see these point-to-point links. Point-to-point means it's a dedicated link. There's only one other connection here. It's not shared. It's full duplex. Shared typically means half duplex, which means you're connecting down to more than one connection. So it's basically a LAN segment. So ISL packet, I'm not sure why we're seeing that, but we are. But we have point-to-point now, which is what we want to see. On switch 5, do show interface trunk. We're going to go to, you can do this all in one fell swoop as well. So interface range PO35 and gig 2/1. We're going to come in here and type in spanning tree. Link type is point-to-point. On switch 4, same thing here. Show interface trunk. Go to global config. Interface range PO24, PO46, and gig 2/0 through 1 and gig 3/0 through 1. Spanning tree link type is point-to-point. So what we're doing is we're trying to add the optimization into the network that we need. and we're going to continue this up to switch 3. This guy's still doing a lot of stuff in the network. We'll go ahead and do you all, which is going to disable all the debugs. As you can see, there's debugs being sent, or I'm sorry, BPDUs being sent out on all the interfaces every second, or every 2 seconds. So as you can probably tell, it's a lot of overhead. So I'm just going to let that finish doing its thing. Eventually it should catch up. So I'm going to go to switch 2 and get him situated. So do show interface trunk. We're going to do interface. Actually, we got a small problem here. Do show ether channel summary. Okay, so everything should be up and running. Do show CDP neighbors. Switch 4 is good. Do show IP interface brief. Do show run interface port channel 24. Ah, that's why. So on switch 4, I bet you any money it's do show run interface PO 24. That would be why. So let's go ahead and just copy and paste this config over onto that side. Switch 2. So we're going to say do show ether channel summary. We're going to say interface range PO 23, PO 24, and PO 12. We're just going to copy and paste this config right here to get them all squared away, and make sure that they are so once that figures itself out, incompatible with. So it says gig 2/3 is dynamic. So do show run interface gig 2/3. Okay, so I'll come back to this later. I'm not going to waste my time on that right now. And we're going to go ahead and just do show CDP neighbors. And we're going to say interface port channel 12. Just right click and copy that config in just like so. So there we have it, folks. That's everything we needed to have. Is this guy squared away now? So do show ether channel summary. Apparently, okay, so we have a problem with port channel 24. But the case in point here, we come out here and do a do show spanning tree. We're going to see that we're going to have a bunch of point-to-point links, which is what we want to have. I can put the point-to-point links on any link if I wanted to. It just makes a lot more sense with port channels to do that. But I could do that on any port if I wanted to. That's going to help speed up convergence because you're going to fail over right away. That's one of the nice things about this. So if I go to R1, PC1, and I hit the up arrow, let's ping 10.1.1.100. Not reachable. Let's go to R1, try him. So we have a small problem. So switch 1, let's go ahead and do a show CDP neighbor. Show CDP neighbor. So we want to be able to ping really slow. So we can ping locally, and I should be able to ping ping 10.1.1. and we want to ping .6. Okay, so I have, okay, so that means I have reachability through to switch 4 or to some other path in the network. So I have some sort of issue up here in the core that I need to get figured out. But the capability here, I'm not too concerned about this right now. I will figure out why this isn't working later on. But the idea here is being able to prove reachability throughout the network. So if I go back up to ping 10.1.1.100, okay, there it's working now. So it just took some time for whatever reason. There was some slowness in the network, and it just took a little longer than I was expecting it to. Not a big deal, but it's one of those things that just obviously needs to be thought about. Why is it not working? So beyond that, that's pretty much everything that I had to show you guys in this video. We're going to start moving on to the theory for multiple spanning tree protocol in the next video, taking a look at that. Until next time, guys, take it easy.